Welcome everybody. This is Tony UC de Velez, Tony UV from VERSPRITE here with the managing leader of our VS Labs group, Robert Hawes. Robert, how you doing today?
Doing all right, Mr. Tony. Things are going great. I'm excited for the talk. Hopefully we can share some good insight and help establish that difference between bug bounty and security research today.
Absolutely. Yeah. So, let's just dive right in because, these are short talks and really the intention is to educate, share some knowledge. So let's dive into the differences. Researching vulnerability research, that term right now, you get a lot of different confusing definitions on what is vulnerability research. How would you define vulnerability researcher as a leader in the for VS Labs?
So that's a great question. Here at VerSprite, a lot of what we do is going to be catered around hardware, software-based targets, normally operating systems, and maybe even some of the more interesting targets, maybe industrial control systems and SCADA software and stuff like that. It's interesting because normally VR, it comes in many different flavors. Specifically for what we do is going to be more binary-based approach. We're going to be looking at the clients themselves, looking at the software, looking at vulnerabilities within the host operating system, seeing if maybe applications that are built on those platforms are vulnerable. A lot of those type of different approaches are utilized, but it's very important to differentiate between vulnerability research against different platforms. So web app-based vulnerabilities and those type of categories are a lot different than software-based vulnerability research and approach.
Yeah, absolutely. And, just from a kind of a status quo perspective, what we're seeing with a lot of different customers and just industry partners that are out there is that there's an increase in prevalence of so-called researchers that are coming out and doing responsible disclosure against different target global entities. We see a lot of companies that are receiving requests from researchers globally saying that they're basically their website, their web application, some level of product is not in conformity to security, countermeasures and so forth. But to your point, there is a major difference, a big spectrum of the quality of research that's out there. Finding, XXS or another type of application, web application flaw with a pre-existing known weakness or vulnerability is different from like finding 0 days and end days, right?
Yeah, so finding XSS is definitely an interesting type of bug. However, I would say the required skill or maybe approach and methodology can be a lot different between doing reverse engineering of a binary and then using automated tools to go find cross-site scripting.
Yeah.
Once again, there are novel cases in both with XSS. However, it's normally a lot more straightforward and a lot easier to find, and people report them in large amount of numbers. So.
Let's talk about bug bounties for a second. So, obviously there's a couple different players out there that have, been in the market for a while, that are crowdsourcing, for lack of a better term, global researchers to come and basically kick the tires on your corporate enterprise, your external network space, or your products. And so a lot of companies have actually subscribed to taking part in this type of effort. And so what do you think are some of the wins and fails of traditional bug bounties as we know them today? I'll have some thoughts to chase yours too, so I'll let you talk.
No, that is a great question. So let's start off with some positives. So some of the great things I think that are very interesting for the bug bounty scene is that they give you a large breadth of researchers to potentially pull from. Now that comes at a great con as well, because the vast majority, the quality is going to be very low compared to a higher research engagement where you have targeted researchers with years of experience looking specifically at a product for you. With the bug bounty approach, it's more of a mass quantity over quality type of scale. And I think we're going to touch on that later in the talk as well. So those are probably the two major pros and cons. Pros, you have a lot of eyes, a lot of people looking at it. A con, quality. You're going to see a lot lower type of impact. You might once in a while see some novel research, see some type of attack that's high impact. However, vast majority of what we're hearing from vendors is that they're getting low quality submissions, lots of low quality reports, hit or miss impact. And a lot of it's gaming the system. And the reason for that's because when you're dealing with bug bounties and you're dealing with trying to maximize as a researcher, so if I was a bug bounty researcher, I want to maximize my return on investment. So what I'm going to do is I'm going to target known vulnerabilities. I'm going to target all the stuff that's already known, that's automated for me. I might add some tooling of my own a little bit here and there to try and spice up the findings. However, the reality is that majority of the researchers are going to be finding a lot of the same bugs, especially when a new vulnerability hits the market, like VPNs, or maybe there's a widely used third-party service that has RCE that gets discovered within that. A lot of those bug bounty platforms are going to see a huge influx, especially if an exploit becomes public, because it's easy to do, it's easy to replicate, and it's easy to get that quality, or not qualities, I apologize, quantity of reports up for submissions on these platforms. So that those are the two major pros and cons from what I have seen within the bug bounty space.
All great points. I have some points of my own I wanted to share with you and see what you thought about them. My summation is this. In the beginning, I think there were some companies, some ideas around let's try to do crowdsource security research, but what it ended up doing is really crowdsourcing pen testing, and a lot of companies that are out there that have looked to reduce the cost of pen testing and expand the scope of time, because when you do a pen test, it's usually from point time A to B. They said, well, let's just have a pervasive pen test that is called a bug bounty, right? And so it goes on for maybe months, and you have different individuals from around the globe that can subscribe and submit their bugs as they find things to call your baby ugly from a product standpoint or website standpoint. So I think the marketing to some degree is to blame in terms of like how it's been sold. Bug bounties has how it's been sold, because it's really just glorified crowdsourcing of pen testing to lower the cost of finding flaws over a greater period of time. That's more, has a greater longevity than the standard pen test. But it goes back to some challenges on a couple of things. Some things that you've already noted, quality for sure, and you don't know, you can't really vet the individual that's out there, right? You're relying on a broker, an intermediary, to go and allow people to come into a bug bounty program and then to kick the tires on your product or your web application. And you don't really know the quality there. So from one bug bounty program to the next one iteration of it, you might get totally different results. So that's one. Also, you don't really know who's really kicking the tires on your product, right? What are the intentions, or could they be doing some level of recon through the medium of a bug bounty program? Why, turn in an O day on a product or a web app when you can maybe monetize that on a different market, right? I mean, do you want $500, $1,000, $2,000, even $5,000 as a payout when you can take an O day, and if it's a really good O day against a product, and let's say you're pen testing a product that is actually included in the supply chain of multiple other products, why would you have a payout for loose change, if you will, when the researcher can basically pocket it and go to an open market? What are your thoughts on that?
Now that is a very great question, and a lot of it comes down to this concept of bug bounty platforms trying to create moral compass, so to speak. What's wrong, what's right. The reality is that you have no way to really vet these researchers. Anybody can come in and join these platforms. Some of the more I would say like prestige bounty platforms are going to have test cases, challenges in the way to vet like certain skill levels before you can join. Those are going to be a lot better, I would say, versus just a public bounty in general where anybody can join. A lot of it comes down to you really have no control over what happens with the intelligence found. I mean, if let's say a researcher finds a third party product and they find some vulnerabilities, get some 0 days out there, does it really make sense to burn that 0 day for $5,000, maybe 10,000, or are they going to go pocket it, try and hit as many targets as they can, or are they going to sell it on their own to maybe some brokers or some other product or other parties? You really have no control over that as a product company, or even just a company in general. Maybe you're using these third party products that these vulnerabilities are found within. So normally whenever you have like a research engagement and even pen tests, a lot of that stuff's under contract. Whatever you find, you have to disclose. And there's going to be a lot less risk for a company going that targeted approach where everything's held, under corporate agreements, and it's a lot less risk, I would say. But at the end of the day, it comes back full circle. It's really a marketing flaw where companies have been, I would say, not negatively persuaded, but definitely misguided in what bug bounties are. The concept is that you can put out these low payouts, and you want to hope that researchers come in and they find these high impact vulnerabilities, and you want to justify that as a pen test, or even as a way to say your product's secure. A lot of times whenever we're reporting vulnerabilities, we'll have vendors come to us and say, hey, we could have found this with our bug bounty platform, but the reality is you didn't. A lot of times you're not. A lot of these vulnerabilities we find, they're not going to be easily automatically detectable vulnerabilities. A lot of times it's a lot of time spent performing research, performing reverse engineering, looking for vulnerabilities manually, whether we do it dynamically or not. It's years of experience plus targeted knowledge into a domain, targeting a specific product, and that's what leads into high impact vulnerabilities. Obviously, luck can play a part, but we don't want to base everything off of luck. We don't want to come out here and hope we find something. The goal is that with a lot of experience and knowledge, you can come into this area of research and be successful, especially when you're looking at the moral compasses around, hey, if we're selling these products or if we're buying them, if you're a bug bounty researcher and you're a company, how do you know that bug bounty researcher is not really a criminal hiding as a researcher? You really don't know. I mean, I remember I've joined up on some of these platforms in the past. There's not really much verification to sign up and join. You just create an account, log in, and then you're free to go. You create an account. Maybe that platform says, hey, put this in your name and we're going to whitelist you for everything. There are some risks with that involved. I mean, there's no way to know who I am on the other side of the computer. That's a scary thing to think about.
Yeah, so many great points there. I mean, I just want to kind of highlight some of the things that you mentioned, beginning with the last point. You don't really know. It's funny because, I've worked for a lot of different multinational organizations, and they always want to know about the vendor. What is the vendor's background? What are the vendor's people? Where are they background checked and stuff like that. In the bug bounty program, you have a lot of unknowns, right? And you don't really know if I'm a someone that wants to do intel and I want to just hop around from different bounty programs. It might be a way for me to understand a little bit more about the target organization versus if I'm just trying to do something on my own as a nefarious threat actor, where I'm just, looking at everything black box and without any sort of, context. So, there is that aspect of it. The other thing that you mentioned was a very good point where I know that you and your team have done responsible disclosure, and we'll get into the morality of things in a second. Where you have, come to a product-based company and said, hey, your baby's ugly in this, and here, there, and somewhere else. And, the rhetoric back is, well, thanks for sharing. We probably would have found this out with, bug bounty program. And, I want to make it clear that everyone's being, hunted, right? There's everyone has a bug bounty program on their organization. It's either established with that decide to go with a bug bounty program externally, or just people are going to just basically hit your app. You're going to hit your product. They're going to download your product. They're going to try to reverse engineer it. They're going to try to put debuggers on it and things like that to try to understand how they can break it and hack it. And you're hoping that they do responsible disclosure, right? Maybe they don't. Maybe they are looking for payouts. Maybe they're looking to do extortion. Maybe they're looking to sell a no-day. These are all the realities of it. So everyone has to really understand that everyone is being hunted, right? Everyone is being hunted. It's just a matter of how you want to channel the findings and find the flaws in your products and services sooner rather than later. So let's dive into really quick because we only have a couple minutes left. The morality of it all, right? I remember when we were building out, in the early days, the VS Labs team. There's this notion of like, well, if you reach out and say your product or application is weak, then there should be a level of, hey, just mention that to them with no time limits. And I think the morality comes on both sides. So let me speak you can speak from the researcher side. I'll speak from I'll play the role of a product owner. And if someone comes to me and says that my product is vulnerable and they give me the exploit code and they show me the impact, and I know that my product is found within, let's say, multiple other products, maybe some machinery, maybe some automotive, embedded systems, then I have a moral obligation as a product owner to make sure that my stuff is correct, because I'm affecting, infrastructure, maybe critical infrastructure. I'm affecting, human life potentially if it's a medical technology equipment that's affected. So everyone talks about the morality on the other side of the coin. I wanted to basically own up on behalf of a kind of a hypothetical product owner simulation here, that there's also a moral play and ethical play about being able to fix your products when responsibly disclosed. Now, can you talk about the researcher side of things in like 2 minutes for us, Rob?
Yeah, so we can definitely try and dive into this topic within 2 minutes. It's definitely a large topic to talk about, and maybe in the future we can do another talk where we go over some of these other concepts. I think that'd be very important for people to understand as well. However, so when you're talking about the moral compass and what's correct for researchers, most of the time I would say it really comes down to wanting to really make a change in the world, in the products around you. You want to make sure that the products your family's using, you want to make sure the products that, if you go to a hospital, is a medical device secure. Are these people relying on this type of technology to survive? Are they going to rely upon, this? Maybe there's like industrial control systems harboring, nuclear type of plants. You want to make sure those are secure. You want to make sure all of that's safe. It's very important. So for a lot of researchers, I feel that there is definitely a big moral compass in play, because when you're reporting these vulnerabilities, there's two sides to it. So one side wants to say research is free entirely, and if in a perfect world, if we could go out and secure all the products for free, that's great in a perfect society. However, in this world, people have to survive and they have to live also. They have bills to pay, they have families. So you have to also think about, well, how do we justify cost with this research to protect these people? And that's when it comes into play of like this concept of, the 0-day markets versus the public bounty programs, which is an entirely in-depth conversation. There's been a lot of people talking about that topic that have covered a lot more in detail than I have. And, it's definitely a long topic to dive into. But I think from a moral standpoint, I would say most researchers publicly facing are doing it because they care about it and they want to see a change in society and the products everyone uses and depend on with their lives. You have GPS technology, satellites, you have airplanes. There's a lot of different areas of research that can happen where people are securing stuff day in and day out, whether they're being paid or not. There's a lot of research that goes into free open source projects, whether it's vulnerability disclosure, and that's awesome to see. I really enjoy seeing those projects happening.
Speaking about the different types of research, can you explain for the audience that might be, hearing a lot of the terms that we've used, like 0-day, end day? What are the simple definitions? What are the differences? And tell us a little bit about like how are you guys, in VS Labs actually, addressing, finding some of this, some of both.
Oh yeah, definitely. So 0 days originally started out as this concept where once a vulnerability is discovered and maybe nobody else knows about it and it's not patched, it's like a 0-day. An end day is going to be something where the vulnerability is already known. It might be publicly released and patched. So every day after that patch and public knowledge is aware of this vulnerability, the end becomes incremented. So it could be 1 day, 2 day, 3 day, and the list goes on. However, people don't normally refer to it that way, so they're not going to come out the back of the shop and say, "Hey, this is a 40-day, exploit." That's not what they say. They say it's an end day, and end is just an incremental variable that can be modified along the way. And normally, when you're approaching this from like a VR perspective and you're wanting to find vulnerabilities, you have a lot of different approaches. There's lots of different ways. People do static analysis, dynamic analysis. People use fuzzers. There's all kinds of different methodology for fuzzing. I know some places are trying to incorporate AI and machine learning, which is insanely, I would say, popular. I'm not sure how effective it has been. I know that there was some competitions utilizing, machine learning for very small, precise type of attacks, but there's a lot of money in that area as well regarding research. But it's important to understand that, when you're looking at these bug bounty platforms and you're looking at research, you really have to approach it from the mindset of saying, hey, research can be anything you want it to be. It's not just VR. We do a lot of vulnerability research and exploit development, and that's great. We do a lot of different testing. However, think of it also as an external research arm for your own company. You can come in and say, hey, we have this product we're developing, and we want to know maybe what are the inherent flaws of this operating system versus another. What are some of the things we need to worry about? What are some of the concepts that could really plague our entire product if we use X operating system versus another? Or maybe you want to think about, hey, we want to create this type of product and we want to look at, what's the normal attack vectors or attack surface that we need to be concerned about for our product. Those are different areas that not specifically VR and exploit development related, but they are very important in the product development lifecycle. And that's what research can help with. You get that years of experience, targeted knowledge, and they come in and provide that guidance. And with the bug bounty platform, you're not really you're not going to receive that type of, I would say, guidance in like a report. And most of the time it's going to be, hey, here's this finding, here's this flaw, here's an impact. And that's pretty much it. So with research and a lot of other services we have, as we mentioned earlier, we were looking at, a lot of these companies getting in these low quality reports. And it really comes down to, especially from the VS Lab side, when we're reporting vulnerabilities, it's really easy to spot a company that has a mature security program versus those that are still starting up and getting ramped up. The way they handle the entire report process, the way they handle the disclosure, the way they handle remediation, a lot of that shows how mature your program actually is. And there's nothing wrong with getting your program up and running. The important thing is getting that established. And at VerSprite, there's different services you can look at alongside research that can help you. We have the threat intelligence side that can come in and help with some of the early adoption of, understanding and setting up this, I would say, like kind of like an internal PCERT team that comes in and handles these incoming researchers that are submitting vulnerabilities in your applications and products. And they can help not only provide intelligence in that side, but also on the threat side. They could tell you where those vulnerabilities might have already been exploited on your networks. Those things all play a key role. But, like when it comes down to end days versus, 0 days and some of the different terminologies, it's hopefully that helps explain some of that.
So is it safe to say, in your opinion, then, like a while ago, a couple of years ago, I had a revelation that I didn't know before in my early years in InfoSec, that the CVEs that are oftentimes, the CVE IDs that are oftentimes acquired from when you submit a bug that you find as a researcher and you get an ID from MITRE, they don't necessarily have to have exploit code, right? So is it safe to say that those types of vulns that are found and that are disclosed, those are, though, that hundreds of thousands that are listed out are end days, right?
Yeah, so that's a great point. So basically, you don't have to have an exploit to get a CVE ID. And that's very important, because if that's really happening, people are having that misconception. That's very important we set that straight, because when you report to MITRE, all you need is for the vendor to acknowledge, hey, this is a potential vulnerability. And sometimes you don't even need that. You can just have a potential POC that could lead into the, once again, potential. Lots of words of potential here, and I'll touch on that in a second. So when you're reporting to MITRE, you have this huge array of potential vulnerabilities, potential exploits, potential info leaks, denial of service, and all of this stuff. But what does that really mean? When you're looking at it from like, hey, I have this automatic vuln scanner. It's telling me all these vulns, telling me all these CVIDs. What does all this mean? It really has to come down to how you interpret that data. Because if you don't know how to interpret it, you're going to be really scared. You're going to be thinking you're vulnerable to everything. But the reality is that a lot of these CVEs, they're not really just a complete exploit by themselves. A lot of targets require multiple types of vulnerabilities or primitives to achieve an exploit in the first place. So you think about different mitigations. Maybe you have like SEH, maybe you have ASLR, you could have like PAC on ARM-based processors. There's lots of different types of mitigations that are going to require multiple different vulnerabilities to get to that single exploit. So when you're seeing like Adobe, for existence, it has ASLR. A lot of times you'll have people listing, all these different CVIDs. Not every single one of those is going to be exploitable by itself. You normally have to chain them with other bugs, unless you get lucky. I mean, maybe you have an unknown technique that nobody knows about. But the reality is that CVEs do not equate to exploits. CVEs equate to a vulnerability or a potential flaw, and that's it. However that's utilized is dependent upon the researcher, or maybe it's a criminal attacker trying to exploit software on your internal network. Who knows?
Yeah,
but
absolutely.
that's how that works.
Yeah, great points. We got 3 minutes to wrap up here. It's always great rapping with you on this stuff on VR work. And my final thoughts, and then I'll let you have your final thoughts, is just to kind of summarize everything. Beginning with what you just mentioned with CVEs. This is not a dig on CVEs or CVSS scoring or anything like that. I mean, highly useful. And the work that's being done by Mite are very useful, but it's what Robert just said. You got to know how to interpret the data. Do you know if the CV has active exploit code that actually works, right? Because sometimes organizations are actually chasing the wrong thing. They don't really know about the viability of a vulnerability from being popped or being exploited. Second thing, we talked about, some of the true vulnerability research that's done from security researchers like Robert and his team at VS Labs, and the time it takes, right? When Robert, you and I know this, you have a lot of peers out there in different organizations. Some of them are flying solo as security researchers in the dark, and they're taking a lot of time and effort. But when they find something and then they have proof of concept, I mean, it's a sniper rifle in the bullseye spot. Organizations need to take note that that type of researcher is different from the researcher that you are probably going to get when you go to a bug bounty. Just because the marketing speak says the word bounty or the word researcher on there doesn't mean that you actually have. I look at it like as the Uber car ride service for finding flaws. Maybe you have some spare time as a professional, and maybe you want to go in there and take part of a bounty, get an extra 2K on the table. But if you're really going to drop something that's going to be jaw dropping, you're going to spend some time in looking for a 50, 100K payout, right? That's going to pay dividends as a researcher. Those types of researchers are at a different league. And really that's what, VS Labs and you're about, right, Robert?
Oh, definitely. I think there are some few researchers within the bug bounty scene that do that already. However, they're vastly outnumbered by the majority of I would say the applicants in the bug bounty world. There's nothing wrong with that, but it's definitely something that need to be understood and have it clear and concise. There's a lot different between reporting a bunch of cross-site scripting vulns and just having like a checkmate type of vulnerability where you just drop the bomb. I mean, there's a big difference, and the amount of time and effort that can go into those type of vulnerabilities and exploits, or maybe even some people call them like full chains, it's definitely a time investment and quality, I would say. But that was a great talk today.
Absolutely. Great. Always talking with you, Robert. And thanks for those of you that partook and listened. Hopefully this was helpful. We'll catch you in the next round. Take care, everybody.